we'll start film. You know, if you watch the last video, I turned it off rather than turned it on, and then when I got at the end, I turned it on rather than I turned it off. So it was kind of an inverse. It's a technology issue in which everything that I use is smarter than me. So I apologize for that. I'll try to do that. Okay? So I talk about this at the beginning, that optimization problems are problems simply in which we find maximum or minimum points, the turning around points. So again, the difficulty is how do you come up with a function that we want? And I'm going to go through a series of problems on how I go through to do that. Now, some of you come up with some means that are highly creative and very successful. I've always believed if you have a way to solve the problem that's different than the way that I solve the problem, don't ever lose that ability, because you got to make sure you get it right. Correct? It doesn't do any good to come up with an answer that's wrong. But a lot of you come up with ways, hey, I looked at it this way and was able to solve it. If that's the way you can solve it, that's perfectly okay. All right. So just to review, turning points of functions are relative maximum or minimum points. The tangent lines at these points are horizontal and have slopes of 0. That's the whole idea. Okay, so I give you this one, and it's in the form of this. H of t equals a negative 16t squared plus v sub 0t plus h sub 0. And I keep bringing that up because, like an equation of a tangent line, AP expects that you know how gravity affects an object that is tossed in the air. So this object, this describes the height of an object that is released with an upward velocity of what, Nikita?
Negative 16.
That is gravity, okay? So you'll always see that number in here. I think if you're, anybody taking physics in here? It's a negative 4.9, correct? Because they, right? It's a negative 9.8 t squared?
It's 1/2.
Right, it's a negative 1/2 g, correct? But when you solve that, it comes down to a negative 4.9 t squared plus v sub 0 t plus h sub 0, correct? Because physics does meters per second, correct? I wish we did meters per second, but AP does feet per second. So this is what I call the gravitational constant. Or as time increases, doesn't the degree tell you what's happening the most? Right? Over the long run, doesn't gravity pull you back? As long as you don't enter outer space, right? So this is the initial velocity. That's what v sub 0. So in here, Nikita, what's the initial velocity?
5.
5. 5 what?
Feet per second.
Feet per second. So this h sub 0 is the initial height. So in this case, Aaron, the initial height is what? 20 feet. Perfect. And so what I did is I plugged some numbers into a table. I always encourage you to do that if you're kind of lost. You can't use, that can give you direction, that can't be your reason why, and that can't be your work. Does everybody understand that? The calculus has to be the work. Calculus has to be the reason why. So if I take a look, at 0 seconds I'm at 20, a half a second I'm at 18.5, at 1 second I'm at 9. I plugged in a 1.5, it was negative. It had hit the ground and gone down deep. So I didn't put it down there, right? So then I graphed it, and my graph looks like this. Then I went to my calculator and graphed it. And I always label this as seconds. And then I didn't make this complicated. I made this 10 feet. Do you guys know that a single tick mark means feet? I learned that in Kruger welding. Okay. And 2 tick marks means inches. Okay. Now, this is where it starts, correct? right? And it shot upward, correct? Right? So it must go up for a brief period of time. I mean, it just doesn't fall down. So I know this is about 18 right here, and this is about 9 right here. So I figured, oh, and with my beautiful drawing skills, I figured, okay, it's got to go like this. I try to hit the dots. Cameron, I'm sorry for my drawing ability. It's the cross I bear. Okay. Which isn't a big deal, but my wife reminds me about it fairly often. All right. So notice there's an optimum height, the greatest height. This can be found by taking the derivative. So I took the derivative. And Ellie, what do we call the derivative of h prime? It's known as the, yes, what's the name for the instantaneous rate? Okay, let's go back to the physics. The ball's being tossed in the air, right? It has a different rate as every moment goes by. Velocity. And the velocity in this case would be a negative 32t plus 5. So that gives me, like Ellie said, if I put 0.1 in here, I'd get 1.8, correct? Right? So if I put at 0.1 seconds, this thing is moving 1.8 feet per second. It's still going up. Well, right here, I know that its rate, or its slope of a tangent line, right here is horizontal, is going to be equal to 0. In other words, it momentarily pauses and turns around. And so that means 5 30-seconds, or 30 seconds, Kruger, 30 seconds, or 0.15625, because I put in my calculator, is how much time it takes to reach its highest height. Can you see that okay back there, Hannah?
Yeah.
Okay. And so I plug that in to my height function. And again, I did use my calculator. And I got 20.9, oh, that's wrong, 20.391 feet. And then Holland, I went to the machine. Did you know there's a band called Rage Against the Machine? I didn't know they hated calculators. That's for my son Sam out there, who might be listening to me. That's sad. All right, now the graph. Delete negative 16x squared plus. Oh, I should have made that my theme song. I bet you could find them in Apple Music, right? Are they popular, Rage Against the Machine? You don't know. Okay. Plus 5x. You even know who it is? Okay, good. Then I'm not the only one, right? Okay, I'm all right. You're making me feel good, Abby. All right, 0. What did I say? It looked like it didn't go any further than what?
21.
No, not 21. 1. Right?
Yeah,
I'm going to go 2. Is that okay that I went 2? And 0 to 21, right? Because I know it doesn't go much past that. So exit draw. Okay, there it is right there. And I've shown you how to find the maximum, correct? On your TIs and stuff.
Yeah.
I see people nod. That means I was doing something correct. And I'll hit it on here. And notice, I got the correct answer. Okay. Next problem. I love the next problem. It's my favorite mathematics problem. You know why? Because I did this when I was 9. So, yes, sir.
So for an answer, do you give like the x or just the
What does it ask for? It says, oh, there's no problem here. On this one, it would say this is the, I would say that this is the optimum height. Okay? And when you take a look at the work that people do on the AP exam, you'll see them do this. So I suppose this thing could travel through the earth. It'd be kind of dumb. And then they plug it into here, correct? And you get negative. I get negative no matter what I put into there, right? What did I just do wrong here? Oh, no. If I put a 0.1 in there, I get positive. What was I thinking? I was multiplying by wrong. I was multiplying by 1, and then I get negative, correct? Because I get 1.8. I even said that a little while ago. Okay, so you can see that this goes in this direction. Okay, so that's another way that they confirm that. All right, so back to this problem. So if you ask me how many cubic inches are in a gallon, I'll automatically tell you 231 cubic inches in a gallon. Because we used to make these trays or these containers for farmers. And their animals would drink out of them. Does that make sense? And so this problem was one of the very first problems I had to do. And it says, what you're given here is an open box of maximum volume is to be made from a square piece of material that is 20 inches on a side by cutting equal squares from the corners and turning up the sides. Find the maximum volume. Okay? So, I'm going to show you a picture of what was done. So I had this little square piece of metal. And it was 20 inches by 20 inches. It was a square. And then what we had to do with that is we had to cut out the same size corners from the square. And what we had is we had a thing called a nibbler for thin metal. And it was kind of like a jigsaw. You guys, anybody in here know what a jigsaw is? It kind of cuts up and down, right, with a blade. Well, this would chunk out pieces, and you'd get little shards of metal that would be taken out, and it would end up like this. Now, Cameron, this is my beautiful drawing again, so I apologize. It'd be this shape, because those pieces would be gone, okay? And then what we would do is we would fold this here. We wouldn't fold it. We had a bender that we used. Isn't that, think about, those were the names my dad called his machines. I'm sure there were more complicated names. The nibbler and the bender. And then it would bend and it would look like this. It'd become a tray. And we would braze. You guys know what brazing is? You know what soldering is? So brazing is kind of like soldering. So if you have soldering, brazing, welding. And so what you would do is you would use a torch and a piece of metal. A lot of times bronze is soldered or is brazed. If you go to a lot of craft shows, you'll see them like blowing glass, but you'll see them brazing and doing metal work. They'll be brazing when they do that. And they use bronze a lot of times to do that. Okay? And so we would seal these corners. Does that kind of make sense? And so that's the volume we're computing. Okay? So what's being maximized, Megan? Volume, right? I'm going to call it V for volume. So here's the hard part. How do you compute the volume of this shape? The one I'm pointing at, Megan. Yeah. Or can I call it length times width times height? Are you okay with that? Because it's a rectangular prism. It's a geometry question, isn't it? Length times width times height, right? And it doesn't matter. I'm going to call this length. I'm going to call this width. I'm going to call this height. The 3 dimensions of that shape, right? Now, I'm going to do calculus on this. This is icky calculus. I don't want this because I got 1, 2, 3, 4 variables. This is a product rule of 3 variables. Oh my gosh, I'm getting a headache now. I refuse to do that because I'm tired. I've already taken calculus for a whole trimester. Kruger, stop it, stop it, stop the insanity. So, Hannah, we're going to come up with 1 variable. And you can choose the variable you want, but since I go to my calculator a lot, and since this thing isn't moving, it's just kind of sitting there, and hopefully it won't leak, I'm going to use x. Okay? And so I'm going to call my function the volume with x inputted into it. Now, let's go back to my beautiful picture. This is the part, Hannah, where you're going to go do analyzation. I mean, I could have made these squares little, tiny, little, right? Little. Right? And that would have affected the volume. Or, Carter, I could have made them bigger, right? Am I beautiful? That would have affected the volume, correct? So in other words, the size of the squares, the volume is dependent on the size of the squares, correct? I can hear it now. My dad said, no. The squares are too big. No. The squares are too small. No. You know, okay. How many pieces? You know, I'm 9. He's having me practice, correct? So, the squares are dependent upon their length. So I'm going to call this x, and I'm going to call this x. So my x is here, and my x is here, right? What's this length right here? Hannah. What's this length from here to here? It was 20, right? And then I cut a chunk out of the top part, right, and the bottom part. So I removed x here and I removed x here, correct? So what's this length? Yeah, that's 20. So that's going to be 20 minus 2x. What about the width here? What about this way, Hannah? Yeah, because it was a square, right? It was 20 by 20. So this is 20 minus 2x. What about the height? What's that going to be? When I fold this baby up? X. So in other words, my function now becomes this, Hannah. X times 20 minus 2x squared. Is that acceptable to you? That's what I'm going to take the derivative of. Why? Because I think it was Megan said we are maximizing the volume. That's my volume equation. And guess what? I'm okay taking the derivative of that because I know I can write it like this. X times 400 minus 80x plus 4x squared v of x is equal to 400x minus 80x squared plus 4x cubed. I'll take the derivative of that anytime. Multiply, subtract, right? Do you agree? Are we okay? Are we okay how we got here? Are we okay with my not so beautiful drawings? Are we okay that Megan said length times width times height? Remember, in calculus, they just want you to know the fundamental shapes, so they believe you should be able to figure out the volume of a rectangular prism, right? Say it again.
Why delete the x by x on the square?
Right here.
Yeah, no, over.
Right here.
Yeah.
Because it's a square, that means I went x distance this way, and I went x distance this way. So I would cut out 2 inches here and 2 inches this way and 2 inches this way, and it would be a square. But I would have to do it 2 inches all the way around. Does that answer your question? Because they're squares. So I got to cut out the same amount. So I would have cut 2 inches this way and 2 inches this way with the nibbler. I would have had a piece of chalk. It kind of funky chalk. It was kind of an oily chalk. And it was flat. And it was hard to write with, but once you wrote with it, it was hard to get it off. I think that's why. Because you couldn't use a pencil because it's metal, right? Are we okay with that? Right, next page. Now, what I do is one of the things you're going to need to talk about is what's the domain. So, can I put, and the first thing I ask, can I put negative numbers in there? Colin, can I put negative numbers in there? Can I put 0 in there? No, because if I look at this, if I do 0 work, I'm fired again from Kruger-Welding, right? And that's what putting a 0 in is, right? That's real. Putting a 0 into here means this volume is 0, correct? Algebraically, I can't put 0, and at Kruger-Welding, I can't do no work. Okay? Now, so in other words, if I come over here to my domain, x has got to be bigger than 0. And I'm going to show you why this is important, all right? Now, let's look at my beautiful picture, right? It comes from a finite. And this is what people say. Well, 20's got to be the max. It can't be bigger than 20. Is that right? What do you think, Colin? Like I'm coming this way, right? Right? With removing, and I'm coming this way, removing. Could I take off 2 from each end? Could I take off 4 from each end? Could I take off 7 from each end? Why not? I go 7 this way, 7 this way. That's 14. I got 6 in there. Can I go 7? What's the maximum I can take? Can I go 9? Can I go 9.5? Can I go 9 3/4? Can I go 10? Why not? There'd be nothing left, right? And look at it algebraically. If I put 0 in here, I get 0, correct? If I put 10 in here, I get 0 also, don't I? Just like Cullen said, there would be none left. If I went, I'd have a dot maybe. I'd have a mess. I did that, by the way. I'm 9, right? This is my first job. I'm getting paid $0.25 an hour. He was okay with a few mistakes when you're 9. Not so much when you're 21, but when you're 9, a little bit more flexible, right? 40, not so much. Okay. Unless you have grandkids, you can get away with it. Okay. So my domain is between 0 and 10. So I'm going to come to the machine. How much time do I have here, by the way? Yeah, isn't that a great feeling? I have no idea. I could be doing this all day. And guess what? I get to do it again next period. Because there are some people that said, there just wasn't enough insanity. I want to do it again. Really? I worry about their sanity. All right. So I'm going to put in, and I like typing it this way. I don't put the whole thing in. I like putting it in as 20 minus 2x, the quantity squared, because it's a lot easier. And I see length times width times height when I do that. When I multiply it all out, it will be nicer for me to take the derivative of, a lot nicer. But I like looking at this. Do you have to do it this way, Holland? No. This is all about me at this moment, okay? And what I'm going to do, I'm going to press enter. And then here, Cullen, is why I do this. When I go to my window, I'm just going to go from 0 to 10. Because it's so much easier for me to focus on what's happening. Does that make sense? And then I'm going to go over here, and I have no idea, not the slightest, how big y is going to be. So I'm going to guess, I'm going to choose 500. I probably should choose 3. I'm going to know what? I'm going to put my real number in here, 333. What the heck? Okay? Is that totally illogical? Yes. But, you know, I got to choose some number. I might as well choose my favorite. Maybe I'll be lucky. Okay. Exit draw. I'm not. Right? I did not go up high enough, did I? Now, for some of you, it doesn't mean there's an asymptote there. You understand? It has a ceiling, right? I just didn't go up high enough. All right, so I'm going to hit I'm going to hit up here, and I'm going to go up. Oh, let's go 1,000. It's got 3 zeros in it, so I'm okay. There I go. I can see exactly what it is, and I could do this: shift, G-solve, max. I even know my answer right there. Look, 3.333. It's like everywhere. You just watch. You know, when you buy a car, that's the only car you see on the road. Really. I see so many black F-150s now. It's unbelievable. It's like I pull in a parking lot, I don't even know where my car is anymore. All right? So everybody see that? I already know what my answer is, don't I? And then what I did is, so my graph looks like this. Now, look at the graph. The reason I bring it up, did the concavity change? You know, it's not important, this problem, but I think it's good review for you to say, oh yeah, I remember us talking about concavity. So it will have an inflection point, right? We don't need it, but those things exist in this graph, don't they? Right? Okay, I can see you wrapping up. That is a clue to me. There's seconds left. Am I right? And we have lunch A, don't we? And I'm hungry. And my what?
It's the second hour. It's a third
Oh, this is the third. I don't get to eat. Oh no, I do get to eat because it's the second hour. Oh, so for some of you, you got to wait till lunch C. I got lunch A. Oh.